Okay, so let's look at another recurrence where we can find the closed form solution using generating functions. And here I'm looking at the recurrence b of n equals 4 times b of n minus 1 minus 3 times b of n minus 2, where n is greater than or equal to 2. Because of this n greater than or equal to 2 business, I need to be sure I have two initial conditions to cover b of 0 and b of 1. And so I have the initial conditions here. B of 0 is 1, B of 1 is 2. Now we're going to use generating functions. So I need to create a generating function. I'm going to create a generating function here. F of x equals the sum for n greater than or equal to 0, B of n, x to the n. And in this example that I'm doing right now, I'm going to try to do it a little bit faster and not go quite as deep into the algebra. I'm going to make some other videos where we'll go through the algebra step by step if you need those, but just to not get too bogged down in it, I'm going to skip some algebraic steps as I solve this. So what I'm going to do is I'm going to take this equation and I'm going to take each of the terms and multiply it by x to the n. And so I end up with b of n x to the n is 4 times b of n minus 1 x to the n minus 3 b of n minus 2 x to the n. And then I can add all of these for n greater than or equal to 0. And so this is the equation I'm going to be working with. Sorry, this should be n greater than or equal to 2, because that's where my recurrence is valid, is at n greater than or equal to 2. So I've gone from this equation to this equation. Now I'm going to look and see, can I relate this at all to f of x that I've defined? And this term is almost f of x. It would be f of x if these matched up. Because these don't match up, this is f of x minus the first two terms. So this term is f of x minus 2x minus 1. Then if I look here, I can do an index shift. So I'm going to go over this in more detail in another video about how to index shift. But basically, if I factor out an x here, which I can do because n is greater than or equal to 2, now I have x times the sum n greater than or equal to 2, b of n minus 1, x to the n minus 1. And now, if I start at 2, but I'm dropping everything down, that's the same as if I started at 1, but I didn't drop anything. So I can rewrite this as x times the sum n greater than or equal to 1, b of n x to the n. And I can do a similar trick here. I can actually factor out nx squared. In fact, I didn't factor out enough here. I should have factored out a 4x. So this is 4x, and this is 3x squared times the sum n greater than or equal to 2, b n minus 2, x to the n minus 2. And now I can do the same trick I did with the index shifting here. I can make this just be, I can make this start as 0, and then this becomes n, and this becomes n. And this, now these are closely related to f of x. This is actually f of x, and this is actually f of x minus 1. So now what I have is an equation, f of x, let me erase this carefully, f of x minus 2x minus 1 equals 4x times f of x minus 1 minus 3x squared f of x. And so this is the equation I'm going to be working with to determine f of x. So let's keep going with this equation, which I'm going to copy back up here.